Hello everyone, and thank you for joining us today. Our webinar is titled Digital Engineering Basics, Product Model Trade Studies. My name is Bob Potok with Zuken, and I will be hosting today's event. Just a couple of things to be aware of before we get started. You are encouraged to ask questions. Please submit your questions in the question window, and we will answer them during the webinar, during the Q&A session, or as a follow-up email. We will also be asking 3 polling questions during the webinar. We're going to share and review the results so you can see how others are responding as well. Your participation is greatly appreciated, and it's always interesting to hear from our audience. So thanks again in advance for your participation. This webinar is part of our webinar series covering digital engineering basics. Part 1 covered product model development using a video drone. That webinar is available on demand. Part 2, today's webinar, analyzes and performs a trade study based on business value on the video drone design created in Part 1. Part 3 takes the result of the trade study and begins implementation of the wire harness inside the drone. We're using a video drone as our example product to make it as real-world as possible. I would also like to thank our co-hosts for this webinar series, Vitech Corporation and Phoenix Integration. They've been great partners throughout the development of this webinar, and we couldn't have done it without them. So thank you both again. And with that, let's move on to a polling question. As I mentioned earlier, it's always great to hear from our audience, and we'd love to hear, what is your current role? Are you a systems engineer, a system or product architect, electrical engineer, a mechanical engineer, other? And if you're an other, if you would just submit that information inside of your question panel, we can share that information as well. Thank you very much for your participation. It looks like we're getting a lot of great responses. They are flowing in. I will give it just another few seconds, and then we'll close the poll and we'll share it with everyone. We are over 80% participation right now. So again, thanks everyone. All right, let's go ahead and let's close that and let's share it with everyone. So in terms of the audience we have today, what is your role? The largest portion being systems engineering at 47%, system product architect at 12, electrical engineer at 13, mechanical engineer at 6, and other at 22, a large percentage. So it looks like one person responded that they're a university member. So I guess there is a education or university contingent as part of the audience today. So again, thank you so much for that. Let's continue on and to the agenda. So today we're joined by Steve Cash, Principal Systems Engineer at Vitech Corporation, and Alex Luke, who is an application engineer at Phoenix Integration. Welcome to both of you, and thank you so much for your help in putting this webinar together. At this point, I'm going to turn it over to Steve, and he can start with the agenda. Thanks, Steve.
Thanks, Bob. And again, let me reemphasize Bob's points. Thank you for participation in the polls. It helps us understand who our audience is and provides feedback on how well we've done today. And we want to be sure we answer your questions. So the agenda today is going to start, and I'm going to start with the first section here on adding analysis to the systems engineering model, the product model. I'm going to transition it over to Alex and let him handle the integration of analysis using Model Center. He'll then also go over trade studies and how you can do that in Model Center. He'll work through then the demonstrations, and then we'll both be back for questions at the end. So I'm going to start with a recap of where we, left off with the last webinar. So we created a model, and what we covered in that webinar was the systems engineering process. It was a systems engineering process that we used to develop the model. We went through requirements refinement. We showed the use of use cases for development of behavior, and then using behavior threading to create that behavior. And ultimately, we gave a very quick overview of the physical hierarchy. We did not take you through a full derivation of the functionality or physical architecture, as that would have taken a very, very long time to go through. And as I said, we transitioned very quickly to this physical hierarchy, one, to enable the discussion here on analysis, and also to be able to hand off the design envelope to the detailed design team when we get to webinar 3. So the picture here is kind of the high-level view of the component hierarchy that kind of shows where the system is. We had the system context, we had the external actors in the system, we had the system of interest, we had the first level of our system components, the remote control, the drone design, and the phone app. We then broke it down into a series of subcomponents and even further to one layer of sub-subcomponents. So where do we go from there on the analysis side? It starts with adding parameters. What are the important parameters of our system and of their components? Well, in this case, we start at the system level. And for this analysis and for this trade study, we focused on business value. We tied in cost and mass, operating range, operational time, the photographic resolution, video image rate, and video resolutions. Now we can set up objectives and thresholds so that we can put that in our analysis and allow us to flex the design to see where do we bring the most value. Likewise, as we move down the layers in the architecture, the system drone, we talk about cost, mass, operational time. We move to something that's a subcomponent like the main battery, and we have battery type, battery capacity, cost, current capabilities, mass, battery voltage, etc., so that we can use those in the analysis. And if we look at something like the flight controller as well, you have a cost, a mass associated with it, and then a power consumption. So you can go through the analysis to figure out exactly what is the best configuration. Once we've identified the parameters, we can create these relationships between parameters called constraint definitions or parametric diagrams. It's essentially a set of relationships that you create between those parameters to create a calculation. So if you look at this as system weight as the item of interest, I've got a drone weight and a remote weight. It's a simple addition. When you look at it from a diagrammatic standpoint, the drone weight is a block and the remote control design weight is only a single item here, but could be broken out very much like the drone weight. The drone weight then simply is an addition of all the components underneath it. Now this is a relatively simple analysis, but it's done this way to demonstrate how you can build the analysis. You've got a set of dependent variables and a set of independent variables. Your output being the dependent, inputs being the independent. So we're going to go ahead and go through and look at two different types of analysis. One, we're going to validate the assumptions of the conceptual design. So as I showed you the parameters as we filled them in at the system level and component level, we're going to go back and validate that as we broke them down, that they truly add up. Everything does make sense. So do they work? Then we're going to pass off to an analysis to look at different design options and determine what is the best fit solution that fits into our business value. In the case of our business value analysis today, we're going to look at cost, mass, operational time, and video resolution. In the parametric diagram, this is what it looks like. I have a business value. It's going to be an external calculation that utilizes the system cost, system weight, system operational time, and the system video performance. Likewise, you can look at each of those. You can see there's a calculation underneath those. For video drone resolution, it's just a parameter that's coming from the camera capabilities. So this is how we'll build up the analysis. At this point, I'm going to turn it over to Alex, and Alex is going to run you through the model center side of this into his demonstration of the analysis. Alex?
Thank you, Steve. Just need to take the control. Perfect.
Momentary pause here to transfer the sharing.
All right. Thank you, Steve. Thank you again for attending this webinar. I would like to start my presentation by sharing this bridge picture with you. This is a famous bridge. I'm sure everyone is familiar with it. Famous or not, bridges are everywhere, and we take all of them for granted. Bridges are important because they connect two different locations separated by a kind of gap. So it can be a river, for instance. And without these bridges, it would be very difficult for us to get from one side to the other. You should ask yourself, why am I talking about bridges? Well, you will understand that in a minute. In engineering modeling, there are two worlds that have been historically disconnected. I'm referring to the world of descriptive system models, Genesis models, for instance, on the left side here, that capture information about the architecture and design, and the world of engineering analysis models, all the models engineers build and run to evaluate how a system performs. Phoenix Integration noticed a lack of connectivity between these two worlds a couple of years ago and decided to develop Model Center MBSE to create a digital engineering bridge between system model and analytical models. To understand how this bridge works and how this bridge creates the ability to verify requirement satisfactions and to run trade studies, it sounds important to first describe the two foundations of this bridge. On the left side, we have the system model foundation. This is what Steve focused on during the first webinar of the webinar series. This foundation is doing a great job to support the system description, its structure, the behavior, and the requirements. Let's focus on the right foundation then, what I call model center engineering analysis models. Model Center will help you automating and integrating your engineering analysis. And we'll see together how these capabilities will help you in your digital engineering journey. Model Center gives you the ability to automate the execution of any software tools. So with Model Center, you can automate just about anything, and we will give you the tools to do it yourself. So we are vendor neutral. I'm gonna consider a simple example here. You developed a model and you would like to automate it and to integrate it with other models. So once again, you can integrate any tool, but we can consider that you have a MATLAB script or a Python script, can be an Excel script, can be a CAD analysis or CFD analysis. What Model Center does is that it puts a light wrapper all around the analysis. It will give you the choice to select the input values and the output values you would like to expose because there are KPIs or because they will become inputs into a downstream component. And finally, Model Center will automate the execution of the tool and the model. So essentially, we have created a black box, and I would really like to insist on that we can pass inputs to and that will automatically generate outputs. So once we have these automated models in Model Center, which can be stored in a library and reused for diverse projects, we will use them to create a workflow. So we can think of a workflow as a flow chart in which we're going to connect the different components and execute them in a specific order. So the inputs of previous models will become, the outputs of previous models will become inputs into downstream models. These workflows can be complex, can contain parallel branches, if statements, nested components. They can be as detailed as is required for them to capture and mirror the steps that you're currently going through with the manual process. One interesting feature that I will mention here is that all of these models and tools that you have in this workflow don't have to be located on the same computer. And they don't have to be on the computer on which you're running Model Center. Thanks to Model Center remote execution, you can run models on the HPC cluster. You can run them at a supplier site if you would like. So this is a really important advantage. Now that I gave you an overview of Model Center integration capabilities, I would like to get back to our video drone example. So in the first webinar, Steve defined the requirements and the architecture of the video drone system in Genesis. for the second webinar, he created simple constraint definitions to evaluate some characteristic of the drone and created parameters. So I used this information to create more refined and complex analysis on Model Center to compute the force, the mass, the power, and finally the business value of the system. So here on the right-hand side, you can visualize the workflow that I created to compute the force during the cruise flight of the drone. So I simply use Python and JavaScript. You could have used any tool. And in this choice of tools depends on the level of fidelity you would like to have. It's still a complex model. There are a lot of variables. So Model Center gives you the possibility to package it up, to package up your workflow. So we come back to our concept of black box. We have a single component here. And you can see here that we only exposed 4 variables, so 1 input and 3 outputs. And it's gonna ease the integration with Genesis proceeding this way. So now that we focused together on both foundation of the bridge, the left part of the bridge during the first webinar and the right side of the bridge just before, it's time to come back to our bridge analogy. So on the left side, we have our system model defined in Genesis, containing the architecture of the system, containing the parameters for the different components. And on the right side of the bridge, we have the different analysis. So we kind of created a library of analysis that we can use. Thanks to Model Center, we packaged them up and we selected input and output values for all of them. So our bridge is going to be Model Center MBSE. So this is what the user interface looks like. This is accessible inside Genesis. And you will see here that we have access to the parameter of the system model on the left-hand side. And we have also access to the variable exposed in these black boxes here on the right-hand side. We will connect these variables together and be able to run the analysis on Genesis together. This is what Model Center MBSE looks like when you open it from Genesis. So you can see here that there are different sections. So the first one represents the structure elements of the system. The second one, the analysis. And the bottom section contains the requirements of the system. So when you fire up Model Center MBSE, it will automatically load system model structure and requirement list based on the system model. You will then be able to connect external analysis to Genesis using Model Center remote execution. So we will create a library of analysis. You will then have to select the analysis to be run, as well as the requirements that you would like to evaluate here. And once you do that, Model Center will automatically pull out the parameters in the system model that are involved in this analysis. You will be able to change the input values of the different parameters and simply click on the Run button and get access to this Result tab. So this Result tab contains the results of the simulation. You will first know if the values have gone up or down for the different parameters and by how much. And also you will have access to the requirement verification status. So here, for instance, we did evaluate the system cost, the video resolution of the drone, as well as the operational time of the drone. We had defined some thresholds, and we can see here that 2 out of the 3 are not satisfied. And this is really useful information. You will have the possibility to save the execution plan and the results, and we will see that during the live demonstration. So Model Center MBSE is great to calculate the business value associated to a given design configuration. So the system engineer is gonna give some values to the different parameters, and we'll be able to see if it makes sense and if the requirements are satisfied or not. But what if your initial design assumptions are false? And what if your design configuration is not good and you have too many requirements and variables? You can, in this context, run a trade study. So you will, when you run a trade study, you run a great number of simulations for different design configurations to further explore the design space, to expose trade-offs, and to find optimal designs. So you will be able to export a workflow to Model Center from Genesis. So this is the visualization of the workflow here in Model Center. So from now on, we are going to run the trade study on Model Center directly. And you can see here that this model and Model Center contains all of the information contained, not all of the information, but useful information coming from the system model. We'll have access to the outputs, to the inputs of the system model, as well as the variables linked to the requirements. So we're going to be able to verify the requirements directly inside Model Center. In Model Center, you have access to a set of powerful algorithms. So best-in-class algorithms that are going to suit all program configuration, and you will be able to run different trade studies. First, you can run design of experiment to explore your design space, to find cause and effect relationship, to compute sensitivity analysis, for instance. But Model Center also contains an optimization and a probabilistic analysis tools to find optimal designs and to carry out risk and reliability analysis. When you run this kind of trade studies, the algorithms will iterate the workflow and generate a lot of data. Model Center contains a great number of visualization tools to make the simulations results actionable, which is really important for you. You have different visualization tools at disposal on Model Center. So here we have two screenshots of a 3D plot on the left. And you can see here, for instance, that we have a trade-off between the operational time of the drone, the cost of the system, as well as the video resolution of the camera. So you have access to a set of optimal designs, and we're going to see together how the definition of the business value can help the engineer to take better design decisions and to find an optimal design based on the market needs. So I will turn it over to Bob for the second polling question before jumping into the live demo.
Thanks, Alex. I will launch our second polling question now. What level of analysis do you perform prior to detailed design? Do you currently do extensive analysis? Do you do some analysis? In your opinion, not enough analysis, or you don't know? Again, thank you for your participation. I'm very curious to see the response to this polling question. The responses are coming in. Thank you. And I am going to ask Alex and Steve to comment on these results. I think this is some very interesting information from our audience. The responses are still coming in. I'm going to give it a few more seconds. Okay. If you're going to vote, go ahead and vote. We're about 80% participation, so this will be a great sample from the audience. All right, I am going to close the poll and I will share it. So what level of analysis do you perform prior to detailed design? So the largest response was some analysis, 39%, not enough at 25%, extensive at 21%, and don't know at 15%. So Alex, based on your experience, does this fit with your experience, or is there something surprising here?
I would say that there is nothing surprising here. I think most of the people, so here system engineer and mechanical electrical engineer, are using some kind of analysis before jumping into the detailed design to have a first understanding and to draft the first version of the design using even like simple scripts. So I think that's normal to see that most of the people here are using some kind of analysis prior to detailed design.
Great. Steve, any other comments?
Yeah, it's not surprising to me either. I think it may have a lot to do with the types of products. You tend to find that the more complicated, the more complex products, they do this a little earlier. As the complexity goes down, it tends to be less. So I think it probably aligns with that a little bit, and it kind of fits my expectation.
Okay, great. All right, thank you both, and thanks to the audience for your participation. Let me turn it back over to Alex.
Perfect, thank you, Bob. So this polling question is now done, so I'm going to jump into the demonstration. I will split this demonstration into two parts. In the first one, I'm going to show you how to evaluate the drone performance and compute the business value directly inside Genesis. So we'll first import the system model information into Model Center and MBSE. I will then integrate external analysis and connect them to parameters, calculate the business value and verify requirements in Genesis before showing to you how to save execution plan and results and how to export the workflow to Model Center to then be able to run trade studies, which is going to be the second part. For the second part, it's going to be a live demo. I will describe the workflow to you. Then I will show you how to configure a trade study in Model Center, and then use a couple of visualization tools at disposal in Model Center to explore the design space and to find optimal designs based on the business value definition. So we'll start with a video for the first part of the demonstration. So you can see here the system model defined in Genesis. So Steve showed it to you during the first webinar. So for this webinar, he created different components and he also added constraint definition to the model. So here we are focusing on the drone costs constraints. You can see here that he defined an expression, a simple mathematical expression here, and he identified a couple of independent and dependent variables used in the expression. We are going to see the parametric diagram, so the view generated by Genesis. So here you have the different parameters involved in this constraint definition. And here we will see the parametric diagram for the system cost. So we are computing the drone cost, or we have the equation of the drone cost here on the left. And you can see here that the drone cost constraint will be computed in order to get an estimation of the drone cost. And the drone cost, the output of the first constraint, will become an input for the system cost constraint. So at this point being said, I will focus again on the components section. So Steve told us at the beginning of the webinar that he created different parameters. So we can see here, we can visualize them. He defined objective and threshold for the different levels. And you can see here that the design section is left blank for now. So now I'm going to go ahead and fire up Model Center. So we'll export the component, requirement, and constraint definition information contained into the system model. And we will visualize the Model Center and MBSE user interface. So what you will see here are the three sections I described earlier. You can see that Model Center is automatically populating the right section here. So we have access to the system's model structure. We have access to some analysis already and to a list of requirements that Steve defined in the system model. So I'm gonna go ahead, drag an analysis into the middle section. And you can see that a couple of parameters have been automatically imported in this section. You can visualize them. These are all of the parameters involved in this cost calculation. I'm gonna go ahead also and add the system cost requirement that Steve defined. So we define a threshold of $350 here. I'm gonna go ahead, I can run the analysis directly from inside Genesis. And I'm gonna get access to the result tab, in which we can first visualize the results in the top section with the variation of the different variables. So you can see if they have gone up or down. And at the bottom here, you can see that the requirement is not satisfied. So the threshold was defined to 350. And here, when we computed the system cost of the drone, we can see that this value is exceeding 350. So we get a red cross. So I'm gonna get back to the execution plan and show you how to change an input value directly from inside Genesis. So we're gonna change the cost associated to the main camera and run this analysis again and see what's the impact on the total cost of the drone. You can see here that the total cost is below 350. So the requirement is satisfied. And I would like to save these results into Genesis to keep track of these results. So I'm gonna click on that and you will see here, Genesis offers me to write the results of this analysis back into the system model. And you can see here that we added this value in the design section associated to the parameter. Here, I will show you quickly how to save the information contained in this execution plan, as well as the results of this analysis. So we can create a GNMC file. We can give names to the different execution plan, to the different result tabs. So here, for instance, it's the cost verification analysis, and we have non-satisfied as well as satisfied cost requirements. So we will be able to open them up and to use it later in the design process. Here, I will fire up Model Center again, but open an existing file in which I added external analysis already. So I will click on Next, and we will visualize the same kind of user interface. But this time, you will see that we have many more analyses at disposal. So we have about 10 or 12 of them. And we just had access to 4 of them in the first part of the demonstration. So I will show you here how we imported an external analysis. So I'm going to edit this analysis, and I will show you how I mapped the parameters with the variables. So here I'm connecting to a server. I'm getting access to a library of analysis that I created using Model Center. I have access to the parameters defined in Genesis on the left side, and on the variable contained in the analysis on the right side. And I will connect the two sides with each other. Give a name to the analysis, and then I will be able to run this analysis directly from inside Genesis. So we'll compute external analysis that can run on a server, at a supplier side, for instance, and you will be able to do it directly from your machine using Genesis. So here I'm selecting different analyses, and I'm also selecting 3 requirements. So the first one regarding the operational time of the drone, that must be bigger than 25 minutes. Then the video resolution of the drone must be above a certain threshold, as well as the cost requirements. So the total cost must be lower than $350. So here we have access to more variables, parameters. We can change the part configuration for the camera and the battery directly from inside Genesis. And I will run these different analyses together. So here we don't see it, but Model Center is automatically created a workflow in the background in order to compute all of the different analyses. And we will see here in the result tab, we have some valuable information. We have access to all of the performance variables of the system. We can see that the video resolution is not exceeding the threshold, so we have a red cross here. Same thing for the operational time. The result is below 25 minutes, so we get a red cross here. But the system cost is the system cost requirement is validated, as you can see here. So once it's done, since I didn't verify all of the requirements, I would like to run trade studies in order to explore the design space and to find possible candidates and optimal system candidates. So I'm going to export the execution plan, and from this point on, I will continue the analysis directly inside Model Center to run the trade study. So I will just show you what it looks like when we just exported the execution plan. Model Center automatically creates a workflow containing all of the analysis as well as the requirement analysis. And now I'm going to jump into the live demo to show you how to use this workflow to run a trade study. So here I have Model Center running on my machine. You can see the different analysis. So I'm connecting to external analysis. I also have access to the different requirement analysis based on the definition of requirement and Genesis directly. And here in the component tree, what is interesting to consider is the structure here. So we get a similar structure than the one defined in Genesis with the different levels, different layers. We have access to the input parameters, to the output parameters, as well as some valuable information about the requirement to know if they are satisfied or not. Here at the bottom, I'm not insisting on that, but this is what it looks like. So in Model Center, you have access to a wide range of plugins, easing the process of integrating models into a single workflow. So here, what I'm going to do, I'm going to change the parts configuration for the camera. So here I'm going to change it to C2, the camera number 2. You can see here that I need to run the workflow to get access to the results linked to this new design configuration. So you can see here a data monitor containing like the useful information about the new configuration. So we have access to the cost, video resolution, the business value, and the system operational time. We also have access to the requirement status. So we can see, for instance, that with this design configuration, all of the requirements are satisfied. So here we have the different trade study configuration that I was talking about. We have access to the design of experiment tool, optimization tool, and probabilistic analysis tool. Just gonna go ahead and click on this DOE button. And here you will see the DOE user interface. So I will have to select the design variables of my analysis here. I would like to change the configuration of my camera. So you have 8 possible candidates for the camera, each of them having different parameters and different properties for the cost, the power, for instance. Same thing for the battery type. And I will also modify the blade radius of the drone. So I will make it evolve between 7 centimeters and 9 centimeters, for instance, with 4 levels. And now we'll have to select the response variables. So I would like to consider important variables here. So the system cost, the video resolution of the camera, as well as the system operational time and the business value. So I'm gonna drag and drop them into this section. And I will also consider the requirements information. So I want to know for each of the design run if the requirements are satisfied or not. I can change the method used here. And once it's done, I'm gonna run it. Go ahead. And you can see here that Model Standard is storing all of the results of the simulation into a table. And we will see here what's happening. So Model Standard is iterating a workflow a great number of times. You can see here that it's executing all of the analysis in a row. And in the data monitor, you can follow the evolution of the results and the change in the design configuration. So this process is gonna be a bit long, so we'll just stop here. And I will open the result of a trade study I already ran previously. So we will have all of the data, the results of the analysis contained here. So I had about 200 runs here. And I will show you a couple of visualization tools offered on Model Center in order to make this data actionable, actually. So here first, you can see we have different options. I'm gonna choose the parallel coordinates plot. So here, the parallel coordinates shows data in multiple axes aligned parallel to each other. So these axes represent different variables under analysis. So we have the inputs here, then we have the outputs and the requirement satisfaction status. Each design point in the data set is represented by a line that passes through the vertical axis, and the intersection between the line and the axis represent the value taken by the design point. So this is really useful to identify outliers, correlation, and trade-offs. So I need to change some settings here because this data is not really readable yet. I need to define objectives. So we're gonna create trade-offs here. I want to maximize the system operational time. I want to maximize the video resolution of the drone. And in the same time, I would like to minimize the system cost of the system. So you can see here that we are bringing some color to the lines. That's great. And we have a constraint tab here in which I will just remove all of the infeasible design from the plot. So you can see here that some configurations have been grayed out because they are not satisfying the requirement. And I can remove them from the plot. I can play around with the different tabs here. I will show to you quickly, for instance, if we are focusing on the system operational time and we would like to maximize it. Well, I can use a slider here. I can apply a filter on the plot directly. And I'm gonna just isolate the design driving to the best value for the system operational time. And you can see that if I'm really focusing on this aspect, the camera number 2 and 5 and the battery number 2 and 5 as well are the best candidates. We can see a first trade-off here. So 2 options are driving to a lower video resolution, but also to lower costs. At the same time, 2 other design configuration are driving to a better video resolution, but also driving to more costs for the system. We can also focus on the business value here to in order to isolate possible candidates and the best candidates. So we have 3 interesting results here that we want to consider, and the business value definition will help us finding best candidates based on the on its definition. So here, for instance, I'm going to change the slider, and I'm going to focus on the designs that drive to the highest value for the business value here. And you can see here that I'm kind of like exposing some candidates. And when I'm just focusing on the best business value results, there is just one camera that looks interesting and promising for us, the camera number 2, and we can still choose between 2 different battery types. So I would just like to conclude, I would like to show you another view. So a 3D scatter plot. Also good to expose the trade-off and to show you how the business value can help us finding the optimal designs. So here again, I will have to play with the settings a bit. I would like to visualize at the same time in order to expose the trade-off. I would like to visualize the system cost. I would like to visualize the operational time of the drone, as well as the video resolution of the camera. And I will color the design space. You can see something really interesting here. So it looks like we have different layers, and I'm gonna expose the Pareto front in order to see where are located the optimal designs. We have a couple of them here, and we can see that we don't have just one optimal designs. We have a trade-off between the operational time, the system cost, and the video resolution. And here the interesting question is, what happens if I decide to maximize the video resolution? Well, we can see that it's gonna increase the cost here between this solution and this solution, for instance, but the system operational time is gonna stay the same. So basically we have a set of optimal designs, and we need this business value definition in order to make a choice. So here I'm gonna expose the business value, and I will apply a filter, and you will see that I will gray out some configurations. I will try to focus on the area where I have the highest value for the business value. And you can see here that I'm targeting a special area of this 3D design space. And if I'm only selecting the best candidates, I'm focusing on this special area of the 3D design space. And I can get valuable information about this design configuration. So I have access to the camera type, to the battery type, to the input parameters, as well as the results. And I will be able to pass these results over to the system engineer and to the business decision taker. So I'm done with the live demo. I hope it helped you getting a better understanding. So I'm gonna turn it over to Bob for the last polling question of this webinar.
Thanks, Alex. That was really interesting information. So this will be our 3rd and final polling question. Would validation analysis in a trade study improve your product design? Basically, the process that Alex just showed you. And again, thank you for your participation. We'll be sharing the results shortly. Great participation this time. Thank you very much. This is another one of those questions that I'm very interested in seeing the audience response, given their experience and their insight in product development. All right, I'm going to give it a few more seconds and then we'll close and we'll share the poll. All right, let's go ahead and close and share that. Again, thank you everyone for your participation. And would validation analysis in a trade study improve your product design? The overwhelming response is yes. I think probably no surprises there, but Alex and Steve, any comment?
No, not here. I think for those that don't know, that's something when you can build on and look at to determine. But from the yes and maybe, it's not surprising. In some cases, you'll be looking at it and see, can it really provide me value? And there are cases where it may not. So the no, yeah, I think it's pretty low. Analysis can help us in a lot of ways, but there are cases where it may not.
I think this goes back to your comment earlier, Steve, about the product complexity, and the value of doing that validation and trade study might be somewhat of a function of your product complexity. Fair?
Absolutely, and particularly if you're in a high reuse type of situation, it may not bring you all that much. So as I said, there are opportunities for some, and in some cases it may not make a difference.
Okay, great, thanks. Alex, any comments?
No, I totally agree with Steve on this one. The interesting question would be if people already used to carry out trade studies in initial step, like in early phases of the development of a new project. And if not, if that would be interesting in applying this method from now on.
Great point, Alex. I wish I could ask a fourth polling question, and I would ask that. All right, great. Thank you very much. I'm going to give it back to you, Alex.
Yes. So I would like to conclude this presentation by presenting top 3 webinar takeaways and to share them with you to make sure that you have a great summary and of the webinar here. So in the first part of the webinar, Steve explained to you how to create the different parameters in the system model. So we would like you to remember how to select the appropriate parameters to create a new system model. Then on my side, I would like you to remember and to understand how to create a bridge between the system model and external analysis using Model Center to verify requirements. And the last point would be run trade studies to understand your design space and to find better designs. So I think that's all for me. I'm going to turn it over to Bob for the questions. So Bob,
all right. Thank you, Alex. And we've got a lot of questions to cover. Let me start with a question from Willie. Did the cost information come from a COTS tool that is connectable to Model Center?
Could you please repeat the question? A COTS tool, you said?
Sure. It's did the cost information come from a COTS tool that is connectable to Model Center?
So there are 2 aspects of that. So when we did the initial systems model, no, it was just a discussion, an estimation done by the systems engineering team to break down the cost. As you get into evaluating real design solutions, being able to pull that cost from your purchasing organization from evaluations of your designs in the trade study is where you'd want to pull that information. Alex, on the trade study?
On the trade study, yeah, for the trade study, I did integrate a couple of analyses in order to carry out this trade study using different kind of tools, mainly scripts. But for the cost calculation, well, the cost calculation, most of the time it's something simple. It's an addition. So you can think of using Excel, for instance, to carry out this kind of analysis. But you could also use other tools, and I would like to insist on that again. With Model Center, you can integrate almost any tool you would like. So if you used to use Excel to carry out this kind of analysis, well, use Excel. If you want to use another tool, it's also possible, and you will be able to integrate and automate it on Model Center.
Okay, great. Thanks, guys. Question from Ruby. Is Genesis static or dynamic in terms of time? If it is dynamic, is it discrete, event, or continuous? I think that one's for Steve.
Yeah, and I'm not sure how to answer that one. So Genesis, from an analysis standpoint, does have a a logic-based analysis tool. It does not have a true simulation environment like MATLAB or Simulink, but it does have a more discrete analysis tool for logical evaluation.
Okay. And if Steve, you may want to respond to Ruby directly to get more information regarding the question.
Yeah, and I will as I get the questions. I'll reach out to Ruby and see if there's more information I can provide.
Okay. Another question from the audience: is the parametric diagram adjustable for readability?
Yes. The parametric diagrams can. So if you look at the business value one that I displayed, I actually had hidden all of the sub-analysis underneath it. So you can tailor the parametric diagrams to show just what is of interest from a visualization standpoint. The underlying parametrics can stay there and be all connected without it being in the diagram. So the parametric diagram in Genesis is just a view, and you can modify that view to display what you want.
Okay, great. Thanks, Steve. This next question, I think, is for Alex. This question's from Thomas. How would the demo be different if we had geographically distributed teams working on the project?
So this is a great question. So during this webinar, I drove you through I was going through different steps to create analysis using Model Center. I mean, to integrate them into a single workflow, to package them up so they could be used directly inside Genesis. Well, with Model Center, you have the possibility to connect and to run models on remote servers or on HPC, and this is our Model Center remote execution feature. And this is what is really powerful to understand. So you can imagine the following situation. You are running Genesis on your machine. You have a colleague that is running a certain kind of, that developed a certain kind of analysis on his computer. You would like also to run a more complex analysis on the server of your company. Well, you will be able to execute these models at distance directly from your computer inside Genesis. And this is the power of the tool. You can really integrate any model from anywhere. And we will explain to you how to do that. This is a really simple setup. So yeah, it's possible.
All right, thank you.
And not more difficult.
Okay, very good. And we are about out of time, so let's do one more question. The last question of the day is from Mary. And can I create my own business value equations for the trade study?
Yes, and in fact, you should, because the business value that you have for your product, for your company, should really be based on the marketing data, the information about your product line that indicates what are the significant requirements, significant parameters to that design. And so if you were to offer your business a solution that was slightly different than perfect, knowing how each one of those parameters affects the rate of return on your, for a given project. If you have the marketing data, that's really where you're going to have the most value in evaluating your design-based solutions against business value.
Great. All right. Unfortunately, everyone, we are about out of time, but I want to thank Steve and Alex for a very informative webinar. There was some great information shared there, and the demonstration was very, very compelling. I hope everyone enjoyed today's webinar, and an on-demand version will be available in the next couple of days for those of you who want to see it again or just want to share it with a colleague. And to learn more about digital engineering, please visit our library of technical webinars. We've got more material covering digital engineering topics. And as you exit the webinar, please take a moment and tell us how we did. There's one survey question on the exit. it would be really helpful to hear from you. And thank you all again for attending, and we hope you have a great day.
Thank you to all of you. Thank you, Bob.
Thanks, Alex.
Thanks all.